So today I'm talking about the VIX index, and I'm going to show you how this index is calculated, what it actually means, and why it makes sense that it is calculated that way. But first things first. So here you see a graph, and in blue you see the VIX index, and the VIX index is also called the heart rate monitor of the market because the VIX index is also always high when the market is nervous. So it's, for instance, high. It has been high during the financial crisis. It has been high during the dot-com bubble. So that's what the VIX is used for. If you want to understand how nervous the market is, you look at the VIX index. And before I show you how the index is actually calculated, we need to go over one side note, and that's options and strike prices. If you don't know what an option is, look at my video on put or call options. I'll link it in the description. So I'll plot some options in this graph. So on the x-axis, you have the underlying of the option. This is the asset that the option is on. And on the x-axis, you have the payoff of the option. And let's say the strike price for my option, for the first option is 100, and it's a put option. So the payoff profile of this put option will look like this. And let's say there's a second put option, but this put option has a strike price of 80. So this will be its payoff profile. So this is option 2 and this is option 1. What do we need to understand? So if we are afraid that the market is going to fall or that a share is going to fall, what's the option that we're going to buy most? Well, we're going to buy most those deep out of the money puts, and they are going to get expensive. So if I'm really afraid that the market is going to fall hugely, then I'm going to buy those options that secure me in this kind of scenario. Why do I not buy those options which begin earlier? Because those options already give a payoff when the market or the underlying is below 100, they're relatively more expensive. So if I'm really just only worried about those big tail risk, strong drops in the asset, then I'll buy those deep, and we call them out of the money puts. So puts with very low strike prices. So now that we've understood what a put and a strike price is, we can actually look at the formula for the VIX. And this is the formula for the VIX squared. So let's look at this. I know it looks frightening, but let's go through it in detail. So this is the risk-free rate. This is the risk-free rate on a government bond for the next 30 days. And then we have an integral here. And this integral is over different strike prices for put options. And what we calculate here is we calculate an integral over all puts with a strike price from 0 to the forward rate for the next 30 days. And we weight them by 1 divided by the strike price squared. And then we take an integral where we start at the forward price and we go to infinity. And now we look at the call options and we weight them by 1 divided the strike price squared. So let's think about this 1 divided by the strike price squared weighting factor. When is this large? Well, this is large if k is small. Then 1 divided by k squared will be large. So what does that mean? So this index will be large if especially the prices for deep out of the money puts are large. So it's very sensitive to movements in puts with low strike prices. So what does the VIX tell us? Well, the VIX will have high levels if put options with low strike prices are expensive. And I just told you this is exactly the case when people are afraid of those tail risk events. So, okay, this formula kind of makes sense, but let's try to understand how people actually came up with this formula. And for that, we need to talk about log normal random variables. So let's say x is a normally distributed random variable, then e to the power of x is log normal. And if we want to get the expectation for e to the power of x, then there's a formula. So the expectation for e to the power of x is given by e to the power of the expectation of x plus 1/2 times the variance of x. This is just the formula for the expectation of a log normal random variable. So let's now make an assumption. Let's say that returns on the market are log normal. This means that S large T divided by ST is log normal, where with ST I denote the value of the market or the S&P 500 at time large t, so sometime in future, and ST as little t is the value of the S&P 500 today. So if that is log normal, then we can calculate the expected value of this. So we assume that ST divided by ST is log normal, so the logarithm of ST divided by ST is distributed normally. So if we want to calculate the expected value of ST divided by ST, we can do this using our handy formula, saying, okay, the expected value is e to the power of the expected value of our random variable, log ST divided by ST, plus 1/2 times the variance of log ST divided by ST. So now I'm going to take the log on both sides. So I get ST divided by ST, the expectation, and the log is given by the expectation of log ST divided by ST plus 1/2 times the variance of log ST divided by ST. Okay, so let's look at this. What actually is this? Well, this is the variance of the market. Why? Because log ST divided by ST is our normal random variable, and we take the variance of this. So if we want to get the variance of the market, I can just rearrange those terms and say, okay, the variance of the market is given by twice log expected value ST divided by ST minus expected value of the log ST divided by ST. And I'm not going to prove this to you, but you can show that this here is exactly equal to risk-free rate times our integrals. So the integral from 0 to the forward price, 1 divided by k squared, times the put price at k dk, plus integral forward price times infinity, 1 divided by k squared, call price k dk. So in other words, the VIX is nothing else than the variance of the market if returns are truly log normal. So in other words, the VIX is the variance of the S&P 500 if returns are log normal. Well, there's one caveat to this. Returns are, of course, in reality, not log normal. But at least I wanted to show you why this formula makes sense or how people came up with this formula. But even though returns are not log normal, this formula still makes sense. I told you it's still reasonable to look at deep out of the money puts if you want to understand the fear or the heart monitor of the market.